morning, and welcome back to eFAB Expo. We are bringing this show to you to give you ideas on how to improve your business, and hopefully you're walking down the aisle with us. So we just finished up with robotics, and now we're coming down to the ALLtra booth. ALLtra manufactures CNC plasma cutting for both plate and pipe. And typically, they're looking at high production runs to complement thicker steels, and also in addition, I think you can complement laser and water jet processing. So at this point, I'd like to introduce Randy Damas.
Good morning, everyone. Welcome to the ALLtra booth at the eFAB Expo. We're honored to be part of their team of builders here, and we look forward to doing in-person forums in the not-too-distant future. ALLtra Corporation is headquartered in Dewey, Oklahoma, which is in the greater Tulsa area, about 45 miles north of the Tulsa airport. We're a privately held company, started in 1992 by John Aerosmith, who is our president, CEO, and chief visionary. John is an engineer by trade, and ALLtra takes an engineering-first approach to our end users' automated cutting challenges. We produce automated cutting systems for plate and pipe, utilizing the plasma and oxy-fuel processes primarily. Our plate cutting machines range from 4 feet wide up to 30 feet wide, with length about as long as you would want to go, up to 4 plasma stations, dual bevel heads, and up to 12 oxy-fuel stations. Our pipe cutting systems range from 2-inch diameter up to 36-inch diameter, and length up to 40 feet long. All of our cutting systems are designed to a 24/7 high-duty cycle specification with best-in-industry components for maximum uptime. Our technical support is available on a 24/7 basis, free of charge. You simply call our main number, and a technician on duty will answer your call. There's no annual fee, no contract. It's a commitment to our customers to offer the best support in the industry. We have no proprietary wear parts on our machines. Our manual for our customers include actual schematics for your system and exploded view parts drawings down to each nut and bolt and washer with a description and part number. From concept to design, through the manufacturing processes, implementation and support, ALLtra maintains control of all phases of your applications. The right way, the American way, the ALLtra way. We're going to see a video now, a little bit of our plant. Again, during the pandemic, it's been hard to get all of our people together, so we didn't get to fine-tune our video as much as we would like. We'll do some narration, and then we will see a demonstration of our full contour bevel system. We have 140,000 square feet of manufacturing space across 3 buildings. We recently purchased a 10,000 square foot building around the corner from our main building that will be used as our repair center. These 2 large Akuma mills are the highlight of our machine shop. We can mill a cross beam within 1/1000th of an inch. That's nice for us to say, but we also have a CMM machine that we can measure and document the accuracy of these mills. Ample crane capacity, as you can see, number of cranes. We do all of our own painting. You can see our paint line and our paint booth in the back room there, background area, sorry. This is a large system we sent to a customer, 23-foot wide cross beam. This is our production cutting machine, and this is a little bit of an oversight view of our machining area. This is Michael Seeloff, one of our applications engineers, and he'll be demonstrating the programming. Okay, we seem to have some audio technical issues. So you can see the part in Michael's screen, and then in the lower right-hand corner, you'll see where he's applying the bevel angles on this part. So this part will have a compound bevel, a blind bevel, and
So now this is
a
the cut
countersunk
path
hole
offset
bevel.
for the bevel versus where the
So if you
original
look
cut
in
path
that right-hand
was.
corner, you'll see the bevel he's applying.
So let's do a countersink at about 5/8. Now let's go 7/8. This one right here, I'm gonna want pretty small. We're gonna go ahead and drop that down to about 1/4 inch. That's a little bit smaller. Go 2/10 inch. This, we don't really want it firing inside the part here, so we got to bring it outside the part. So we're going to use a interior lead in for that. We're going to go about 7/8 inch. Now you can't actually see it. There's a lead in hidden right there that we need to bring down to about.
This part is manufactured from 1 1/4 inch carbon steel plate.
There's also going to be a lead out right here.
This is the countersunk hole area, which will have a 41-degree bevel, which seems to be the standard in the industry for countersunk holes. So this is our bevel system in action. You can see the range of motion. We use a tilt process. 2 motors give us the 5 axes for our bevel cutting. These moves are made at 1,000 inches per minute, and you can see how smooth that action is. So here we're beveling the hole. And that's the finished part, which I have here.
That's the bottom of the part. You want to see the top of it?
Yep.
In the upper right-hand corner, you see what we call a compound bevel, 2 different bevel angles in that corner. You see the countersunk hole. There's that compound bevel again.
And right here, that's basically
And that's
a
what we
blind
call a
bevel.
blind
So what we did is
bevel.
we just
Bevel.
started
We
the bevel
start with a
partway
straight
down the
cut
profile, just kind of
and tilt to the
drag it in.
bevel angle, and then put the straight cut on that blind bevel. So very impressive. Okay, we're back live. I'm going to grab that part. So again, here's that compound bevel. See how smooth that motion is. We changed the angle during the cut. Here's the blind bevel. Again, a little better look at it. And here's that countersunk hole, which again, 41 degrees of bevel with the land. It's the underside of the part. There was a little bit of dross, but it cleans up very, very easily. Again, ready to weld or put the fastener in the hole. And that part was 1 1/4 plate. This is 1 5/8. This was a end user that drew this part up to show a variety of the things he wanted to do. You can see the sharpness of these points. This was cut at 300 amps. You can see the roundness of the holes. Smoothness of that cut edge. It's a stainless steel part, 3/8 of an inch, cut with the Hypertherm XPR 300 with the nitrogen water process. Very little heat affected zone. Hopefully you see how clean that inside is. And the underside, a little bit of dross at the start. Other than that, a very clean part. It's a weldable edge, no cleanup using the water secondary. And again, these are your run-of-the-mill. Of course, this is a 3/8 part, carbon steel. Again, you can see how sharp that point is. See how smooth the cut edge is, and virtually no dross. And this is a 1/4 inch sample. And very round holes. Very smooth cut edge. Okay, we'll open the floor for any questions.
Great, thank you, Randy. Appreciate you taking the time to answer some of our customers' questions here. And we want to thank you for coming in.
Pleased to be here.
Great. So the first question, realistically, what is the maximum thickness of carbon steel I can bevel?
2 inch, because normally you're not putting a 45-degree angle on 2 inch. There's two choices on the plasma system for carbon steel. There's the Hypertherm XPR 300 system, which will cut, Pearson cut 2-inch material. The HPR 400 XD still exists and will cut a little faster, has a little larger, longer arc. So if you're beveling 1 3/4, 2 inch, the 400 amp would probably be the best choice. Again, that 1 5/8 part that you looked at was cut at 300 amps with the XPR 300 system.
Excellent, great. The next question here is actually on the screen for you. Does ALLtra offer any other plasma beveling options for basic weld prep?
Yes, we do. We have several other bevel tools that will bevel in a straight line. They will not do an arc or a circle. So we have a 4-sided bevel station that's automatic, motorized, and we can bevel all 4 sides of a given part. We have a single-side bevel station, also automated, that will bevel along the x-axis or the y-axis in one direction. And we have a manual bevel station that the operator can set manually to do basic weld prep on his parts. So we've had customers start with the manual bevel station and work their way up to the full contour bevel system. We sell a number of the 4-sided bevel systems, basically for weld prep. That's one of the largest applications for a bevel head. But in recent years, they're countersinking these holes, which used to be a fairly manual operation, or at least another process. So we save a lot of time by doing that on the plasma system.
Great, excellent. Here is another question coming in from a viewer. Is there a rotary pipe cutter option?
Yes, there is. We call it our pipe combo system. So let's say, for example, you were looking at an 8x20 plate cutting machine. We would add gantry width to accommodate this pipe combo system. The standard system will cut between 2 inches and 24-inch diameter. Again, we can go up to 40 feet long. On our largest system, our HG30 system, we have more room under the bridge, so we can cut 2 to 30 inches in diameter on our HG30 system. And it's nice for customers that do plate and some pipe, and you go back and forth with that same bevel head. We use an extended station for pipe cutting. Our standard bevel station offers 24 inches of stroke. Our pipe cutting height control offers 40 inches of stroke. So if you're also doing dome headers and things like that, we can add rail to the machine and cut the holes in those dome headers. And we have standalone pipe equipment. One model is 2 to 30 inches. The next model is 4 to 36 inches. Now, pipe combo is available. It's a fraction of the cost of the standalone pipe. If you were primarily doing pipe, you'd more than likely want the standalone system. But if you're doing pipe along with plate, the pipe combo is very economical.
Excellent. And this question kind of goes in conjunction with that. I hope you were speaking of the bevel angle. So what is the maximum bevel angle your full contour bevel system provides?
Our station goes up to 50 degrees, and the reason we do that is so we can guarantee a 45-degree bevel on all your plate applications. So in the industry, 22.5 degrees, 30 degrees, 37.5 degrees, and 45 degrees are the most common plate angles, and then 41 degrees is most common on these countersunk holes. So in order to guarantee you a 45-degree angle on your part, we allow our head to go up to 50 degrees to make sure. In actuality, you could probably get 47 to 48 degrees with our head. I don't know that there's any applications out there doing that, but that's why we offer 50 degrees on our rotational bevel head.
All right, and we might have a few more questions coming in. Let's see. Getting this queued up. So this question is from a customer. What gases do we need to run this system?
Okay, gases, we use oxygen as the cutting gas, the plasma gas. This is the gas we're ionizing to do the cutting. And we use air as a secondary gas. So steel's fairly easy. There are some thin sheet applications where we may run air. All the Hypertherm systems, be they the XPR series or the HPR-XD series, have an automatic gas console. So as long as you have all your gases hooked up and the bottles and regulators open, the gas console automatically opens the proper solenoid valve. So again, it's oxygen, plasma gas, compressed air secondary from your air compressor for steel. For stainless and other non-ferrous alloys, there's a number of choices. With the XPR series, one of the big advantages of it is using nitrogen plasma gas with a water secondary. It's not high flow water, but this water prevents that oxide from forming on stainless, Inconel, aluminum, that normally you see cutting with nitrogen and air, and then you have a big cleanup operations. So the hydrogen in the water helps keep that edge clean. You can also use hydrogen-argon or nitrogen-argon mixtures as the cut gas with nitrogen secondary. It has the same effect. The hydrogen in these gases, like the hydrogen in the water, reduces that oxide that normally forms and causes that cleanup operation. The nice thing about nitrogen water is you get a very square cut and you still get that very clean cut edge, a weldable edge.
All right, and here's another question. Are the plasma consumable parts, do they differ for standard cutting and bevel cutting?
On some systems, yes. On the XPR series, no. And that's another advantage of the Hypertherm XPR series. It's the same consumables for beveling and straight cutting. The consumables are tapered for bevel cutting because of the angles we're cutting at, and they get close enough to the plate. The HPR-XD series has standard consumables and bevel consumables, so it's a little extra inventory. You can use the HPR-XD bevel consumables for straight cutting, but they don't work it quite as well on straight cutting as the standard consumables for the HPR-XD series. So this is something Hypertherm looked at, and there's one set of consumables now for beveling and cutting with the XPR series.
All right, Randy, here's a good question for you. We're going to kind of put you on the spot. How does plasma compare to laser cutting?
Well, they're both thermal cutting processes. Laser is a more precise cutting process geared toward very high production materials, let's say half-inch and under, you know, very good appearance. So if your parts need to be aesthetically pleasing, in other words, if you're in the food equipment manufacturing business doing electrical panels and such, it's a much more precise cut. Plasma we can do down to 26 gauge material, steel up to 2-inch material. There is an 800 amp plasma system hyperthermometers that will pierce 3 1/4 inch stainless and edge cut 6 inch. So plasma applications normally are for parts that will be welded. You get a very weldable edge, a very clean finish. So if they're being welded, assembled, and so on, plasma is very economical in comparison to laser, particularly your initial investment. If you need to bevel some parts, a lot of people are using straight line tractor equipment or beveling manually or using a mechanical beveling system. Mechanical beveling is very nice, but it's also very slow. So automating that beveling process with the plasma, it just increases your productivity immensely. Laser doesn't have that versatility when it comes to beveling parts. So there are two different processes. There's a place for both, depending on your application.
Excellent answer, Randy. So here we have another question here. Does the controller move with the cutting head on all models?
No, it does not. We have a stationary option for the console. It's basically in a tower and sits on either side of the machine. There's a 7 to 10 foot umbilical cord that's connected to the power track. This machine, we have the controller mounted on the left side, or you can have it mounted on the right side depending on your shop orientation, and it travels along with the machine. On longer footprint machines, it's usually a customer preference for the walk along, so the operator can stay where the cutting action is. On the smaller systems and higher speed systems, the stationary model is preferred, and also for safety reasons. When you have a high-speed gantry going 1,200–1,500 inches a minute on its traverse speed, I don't know that you want the operator having to chase that. So we offer both.
Great. Now here's another question, kind of similar to laser cutting, but how does plasma compare to water jet cutting?
Again, there's a place for all three processes: plasma, laser, and water jet. Water jet is your finest cut quality because there's no heat affected zone. It's an abrasive process, so it's different from laser and plasma cutting. So you will get a very fine finish, a very narrow kerf area. You can cut very thick materials that are sensitive to heat affected zone like titanium, thick aluminum. Water jet cutting speeds are much slower than the plasma cutting process. So again, you don't see a lot of water jet on carbon steel alloys. If the parts are being welded, fabricated, and so on, it's a lot more costly to cut those parts with water jet. And again, there's a place for all three cutting processes depending on your application.
All right, and here's another kind of specific application question. And it kind of sparks the idea that we will, at the end of this, be moderating the chat, and you will have the opportunity to schedule a follow-up meeting with Randy here. So if we didn't get to your question, we do apologize, but we will have ways to get in contact with Randy. But Randy, if you could field this last one here, can you cut stainless steel and aluminum with protective film on the finished surface?
You can. The protective film has to go down. You have to cut it with the material side up. The material needs to be grounded or the arc will not transfer. So that's common, again, in the stainless steel kitchen manufacturing industry, the food equipment industry. Leaving the film on, that side will not get scratched by the slats on the machine. So yes, you can. You just need to have the protective film side down. Thank you, everyone, for attending. I look forward to speaking with you in the future about any plasma or oxyfuel cutting applications that you have. And thanks to Mid-Atlantic Machinery, Southern States Machinery, and Northeast Machinery Sales for sponsoring this expo.